Hello and welcome back. Mr. Wakefield here, looking at, as I mentioned in the last video, a brief trip into Chapter 3. We're going to be looking at sections 3.1 through 3.3. It's going to feel like it's just one section, though, even though it says three different sections here, because in the textbook, when you do your homework, the problems, there's a lot of problems spread out over three different sections, which are all basically under this same concept of solving linear equations. So that's why it says this right here. Okay, but it's going to feel like I said, it's going to feel like one section here. So it's not as long as it may seem to you when you look at this right here. Anyway, this section is the beginning of a number of sections that we're going to be doing coming up here, where you're going to solve a one variable equation. Okay, unlike the two variable equations where we usually graph them, right? And of course, graphing is an illustration of all the solutions, okay? So when you graph a two variable equation with x and y in it, okay, you are essentially showing what all the solutions are. When you solve a one variable equation, again, you are also showing what all the solutions are, but just in a different way. You're not graphing it. What you're doing, and when we've actually done this briefly before, is you're getting x by itself, or whatever the letter is. In problem A right here, you can see that the variable in the problem is a, and so you're going to get a by itself. In this next problem over here, the z is the variable. It's the only variable. There's not like a different letter in there, and so that's why we call it a one variable equation. And again, when you're solving a one variable equation, the goal is to get that z by itself. Now, it's not enough just to get the letter by itself. For example, let's say in problem A right here, and I'm not saying this is going to happen, but let's just say, for example, that you got A by itself, but then on the other side of the equation, it looked like this. What's wrong with that? What's wrong with that is if you have a by itself, but the variable also appears on the other side, then you don't truly know what a is equal to because it's on the other side. And so it's still a mystery as to what it is. And so it's not enough just to get the variable by itself. It also cannot appear on the other side. That's what it means, you guys, to solve for a variable. Okay? It means to get that variable by itself without having it on the other side. So we don't want this. We want to have a by itself, but then not on the other side. For example, we want to get something like a equal to 5 or a equal to 7, okay, but no variable on the other side. Okay, the a could be on either side of the equal sign that you want, okay, as long as there's not an a on the other side of the equal sign. Okay. So that's what it means to solve a one variable equation. Why do we call these linear equations? It's the same reason why we call the problems in chapter 4 linear equations. Okay, it's because, and this is a little bit different here because we have parentheses for the first time, but a linear equation is when, after you clear out the parentheses, and I'll show you how to do that, after you clear out the parentheses, it will be just like the ones in chapter 4 where you have a polynomial on both sides of the equation. It'll only be one variable instead of two, but still you'll have a polynomial on both sides of the equation, and the variables will not have any visible exponents. In other words, it'll be x to the first power or y to the first power. You won't have like x to the second or x to the third, all right? All of the variables, even after you clear out the parentheses, will be to the first power. Okay, you'll just, for example, after I clear out the parentheses here, you'll just see a. You won't see a to the second. You won't see a to the third. You'll just see a. Whereas in the next section that we're going to do after this one, which is section 7.5, you'll see stuff like this. Why is this not a linear equation? It's because you have a to the second power. Okay, you can't have a variable to a second power or third power, okay, when you have a linear equation. And that's important to know because when you do these steps right here, they only work for linear equations, okay? So we don't want to do the linear steps on something that's not a linear equation. This problem will have a different set of steps. We'll see that in section 7.5 in the next video, okay? So, but that's what a linear equation is. After I clear out the parentheses, which is the first thing that we're supposed to do anyway in a linear equation, okay, you'll then see that all you have as far as the variables are concerned is just a. Again, not a to the second, not a to the third, and also you'll have a polynomial on both sides. Okay, we'll see equations later where you don't even have polynomials on both sides. That'll be a little bit of a different story as well. Okay, but these will be linear equations for the reason I just described. And again, I'll keep on talking about that here as we go through this problem. So how do we clear the parentheses? Because it asks us to do that. Okay. Well, as we learned back in section 6.3 on the very first day of class, all right, after, this is one of the problems we did back in section 6.3, after I multiplied 11r squared times 2r plus 7, I did not initially have these brackets here. I ended up putting them in here. So let's pretend like I haven't put them in there yet. That first set of brackets right there. Okay, why did I put those brackets there? It's because I'm supposed to multiply the entire result that I got from multiplying 11r squared times this. I'm supposed to multiply that entire result by that last bracket there. And so I put the brackets there. But what if I hadn't put the brackets there? Why is that bad? Okay, because when you don't have brackets here, you're only allowed to multiply the closest term by the bracket, the 77r squared, not the 22r to the third. But in this particular problem in 6.3, that was wrong because we had to multiply the whole thing. And so that's why I put the brackets here. My point is this. If you have, for example, see how you got two terms right here? But they're not in brackets, right? And then right after that, you got a bracket. Okay, so and it's right next to it, so it's 2 times, right? There's nothing in between the 2 and the bracket, so that means multiplication there. My point is that because there's no bracket around the 3a plus 2, you're only supposed to multiply the closest term, 2. Okay, not the 3a. You got to leave the 3a alone right there. Okay, so that's my point, you guys. If you have on one side of the equal sign, and the equal sign breaks this up into 2 separate parts of the problem here, okay? The equal sign is like a divider that keeps the 2 sides separate. But when you have on one side the equal sign, at the beginning you have more than one term here, but they're not in brackets. And then right next to that, it's pushed right up next to a bracket, okay, where you have the last term is being multiplied by the bracket like that. You can see that this happens over here as well. You got 2 terms on that side of the equal sign over here on the left-hand side, right at the beginning, you got 2 terms that are not on bracket, and then it's pushed right up next to a bracket where the last term is right next to it, which means multiplication right there. Again, when that happens, when you have a polynomial that's not in a bracket, and it's pushed right up next to a bracket on the right-hand side of it like that, you're only supposed to distribute the 2. And do not do 10 plus 2 equal to 12 either. You can't do that because that would be a violation of order of operations because we're supposed to multiply before we add. Okay, and so keep that in mind as well. Okay, I know we don't normally do order of operations when we have variables, but we still have to do things that agree with order of operations. Okay, so unless there's a specific reason that we can do an alternative way, but there isn't in this case. You have to realize that since 2 is being multiplied by the bracket, okay, you can't do 2 plus 10 first before you multiply. All right, it's just like this right here. If you have 10 plus 2 and then the bracket is just a simple number with no variable, like for example, let's say I put a 4 in there. Wouldn't I do 2 times 4 before I do the plus 10? You're not going to do 10 plus 2 equal to 12 though, right? Again, multiplication comes first. And so that's why you got to make sure to distribute out the parentheses here first before you even think about that addition right there. Okay, that's outside of the parenthesis. Which the 2 is not going to even be able to be added to the 10 after that anyway because the 2 is not going to be a 2 anymore. Okay, so you have to distribute first. Okay, just like here where you multiply first. And so, same thing over here again, but ultimately the lesson here is that if you've got a polynomial, with no bracket around it, more than one term. And like I said, it's pushed right up next to a bracket. You got to distribute only the closest term because there's no bracket around that. But don't try to combine those terms first. Okay, these don't combine anyway because they're not like terms. These do combine if you were allowed to. So make sure not to do it because you're not allowed to do it in this case. Like I said, you have to distribute the closest term, and then we'll go from there. Okay. Now, as far as, say, for example, the 3 here, if you have just a single term at the beginning of that side of the equal sign here, here's the beginning of that right-hand side of the equal sign. If you just got a single term up next to a bracket, then you just distribute that single term. No tricky stuff there. And then if the bracket ends and then you have a plus or minus after that, excuse me, a plus or minus after that, then it's just going to be completely separate. Okay? So that you don't distribute to that. One other thing, and it's the same thing here with the plus 7. That's going to be separate because the bracket ends and then you have a plus or minus behind that. That's separate. You might be wondering, well, what do we distribute here? There's no number here. Do we distribute the minus 6? No, we don't because of the minus here. That's separating the minus 6 from what is an invisible negative 1 right here. You don't have to write the 1 right here. I'm just highlighting it. Okay? So, again, if you include the fact that you've got an invisible 1 right here, and if there's nothing in front of the bracket other than a plus or a minus, there is an invisible 1 right there. There is. And so when you distribute, like I said, because you have 2 terms here, and I know it's 2 terms because there is a minus in between them, right? Just like there's a plus in between these, that makes these into 2 separate terms. Okay, there's no bracket in these 2 terms, and there's a plus or minus in between, and that makes it into 2 different terms when there's no bracket there in the thing I underlined, but there is a plus or minus in the middle. Okay, so 10 plus 2 is 2 terms, negative 6 minus 1 is 2 terms. You are only allowed to distribute the closest term if there's no bracket there. So the negative 1 gets distributed to the a plus 9. Okay, so we are distributing there just like we did back in 6.3 where you have a term times a bracket. If you've got a term times a bracket and there's 2 terms in there, you'll see that a lot in this section. Okay, you just multiply to the 2 terms. Same way we did it before in that section. So let's do that here. We just distribute the negative 1, so the minus 6 is just going to come down. You don't do anything with that on this step. You just distribute the negative 1. Now, when you distribute, as we did back in 6.3, I was just talking about, you need to add the results, okay, of what you get, all right? That means you need to have a plus or minus in front of each one of the results, depending on whether or not the result is positive or negative. So, in other words, negative 1 times a, that's negative a, isn't it? So that would be plus negative a right here, but we know that plus negative a is the same thing as minus a. And so we're adding our results, but if it's negative, you can just say minus. Negative 1 times positive 9 is negative 9, so that would be plus negative 9, but again, you could say minus 9. Plus negative means the same thing as minus. And then, like I said, the plus 7, you don't do anything with that on this step. Okay, you don't distribute to that, so you just bring that down. The 3a is like the negative 6. Again, you're not supposed to distribute that. You're only supposed to distribute the 2. And so just bring the 3a down. Don't bring down the plus here. It all depends on how it distributes out. Remember, each result, you got to determine the plus or minus that goes in front of each result when you distribute based on whether or not it's positive or negative. So 2 times 4a is 8a. Since it's 8a, positive 8a, you're going to put a plus in front of that. Okay? All because it's positive. You're adding a positive. So you put plus. 2 times negative 1 is negative 2. All right, so it's plus negative 2, same thing as minus 2. All right, so we did it. We distributed. We cleared out the parentheses. Okay? What's the next step? Combining like terms on each side, right? Now, I want to make that clear, you guys. You do not combine the negative a with the 3a. They are telling you, on this step anyway, they are telling you that everything on the left side of the equal sign is separate from everything on the right-hand side. Separately. Okay, very important. Don't be combining one side to the other side right now. So just keeping the two sides separate, combining like terms, I get the negative a doesn't combine with anything over here, but negative 6 minus 9 plus 7, if you combine those, you get negative 6 minus 9 is negative 15. Negative 15 plus 7 is negative 8. Okay, over here I got to combine like terms. 3a and 8a combine to be 11a, and then minus 2. Okay, and so what does it tell us to do next? This is a part where we did kind of see this already in the early part of chapter 4. Remember I told you that when you have a variable term on one side of a, and this is a one variable linear equation, by the way, and so it actually fits into these steps we're doing right now. It's just that we only looked at a very few number of these smaller linear equations before. That's why we haven't gone over all the steps until now for the one variable linear equations. But we did move over the 7 with the 14 before I divided out. Why did I do that? Well, we're going to find out exactly why that is supposed to be done now. It says in the next step here, and we didn't need to do the first two steps on that problem I just showed you, the 2x plus 7 equal to 14, because there wasn't any parentheses or like terms, okay, to combine on the separate sides. So we jumped right to the third part here, and the third part says this. It says that if you have variable terms in the problem, again, don't do this until you get to the third step, but if you've got variable terms in the problem, terms with variables in it, and you have terms that don't have the variables in it, you are supposed to what? You are supposed to move the ones that I circled here in green, okay, you're supposed to move those to one side, and you're supposed to take the ones that I boxed in red here to the other side. It doesn't matter which side the A terms go on and which side the terms that don't have the variable in it go on, as long as they're not on the same side. Okay, so the two boxes have to go on the same side, and then the two circles here have to go on the opposite side. But it's your choice which side is which. I'm going to go ahead and move the negative a over here with the 11a. And it says here you have to add or subtract, okay, up here in step 3, just like I did here. I had to either add or subtract the 7 over with the 14. Okay, and this was like a box right here. I didn't do that before, but the variable terms are different. Okay, these are like... these are different. That's why I'm circling these but boxing these in, just so you can visualize that. But the terms that don't have the variable in it, okay, are moved over to the opposite side of where the variable terms are. Okay, so because this is negative, I have to add it over. I mentioned that throughout chapter 4 on a number of occasions where when you do that step, all right, where you move the terms that don't have the variable in it to the opposite side of where the variable is, you either got to add or subtract, and it's determined by what this is, the term that you're trying to move. If it's plus, you subtract. If this had been minus 7, you'd add. And that's exactly what we need to do here. Because this is minus a, you got to add. That's going to cause this to cancel out when you combine like terms. You need to combine like terms when you add or subtract the same amount to each side. But combining like terms there makes that cancel. That essentially makes the negative a term move because it cancels out from the left. It moves from the left side to the right side. And we end up with, if I combine like terms on the other side, 12a minus 2. We then what? We now have what now? We now have a one variable term, but we have what? We have two. We still have two terms that don't have the variable in it. So those ones need to be moved to the opposite side. That means that I should not move the negative 8 because then everything will be on one side. Okay. I don't want the circled ones and the boxed in ones to be on the same side. I want the two terms that don't have the variable in it on the opposite side of where the variable went. Since the variable went to the right-hand side, I'm going to move the two terms that don't have the variable in it to the left-hand side. Okay, and that means what? That means to add 2 because this is minus 2. If it had been plus 2, you would have said minus 2 underneath it. Okay, either way, it's going to cancel so that you're left with 12a only here because everything else canceled. And then this becomes negative 6. And then just like I did in this problem back in chapter 4, this, by the way, this is from the section 4.1, 4.2 worksheet, if you're wondering, problem C, okay, if you want to look back at that at some point. You don't need to right now. But after I moved that 7 over the 14, I now had a single term on each side with the variable only on one side. You probably remember me saying that on a number of occasions. Single term on one side with the variable, single term on both sides with the variable only on one side. It's when you have that and you do not go to the last step here, which is to divide out, until you have those things, single term on each side with a variable on one side only. That's when you do the division step. Okay, that's why we divided by 2 here. You divide by the coefficient of the variable term. Don't divide by 7. Okay, same thing here. And it tells us that in step 4, we divide by the coefficient of the variable term. That means to divide by 12. And then the 12s will cancel, and a is what? It is by itself. Put the fraction in lowest terms, okay, if it's not already, and it is equal to negative 1/2. So we got a by itself, and not only did we get a by itself, but it is not on the other side. That's what it means to solve it. Next problem. Okay. Again, we only distribute the 2, right? As we talked about. The 10, just like the minus 6, stays separate. Okay. So we distribute the 2. 2 times z is positive 2z, so I got to put the plus there since it's positive. Okay. Pluses or minuses in front of each term. Pluses or minuses in front of each term when you distribute, and you get your answers. 2 times negative 9 is negative 18, so that's plus negative 18. Same thing as minus 18. And let's keep going here on the other side. As we said, we just distribute the 3 right there. 3 times z is 3z. 3 times positive 1 is positive 3, so I got to say plus 3. And then the minus 4 just comes down. As I said, we don't distribute to that. Okay. Then I do what? Then I combine like terms. Remember, that's step 2 on the top of the page here. Combining like terms on the 2 sides separately. And there you go. Okay, now what do we have? Now we have 2 variable terms. Okay, in other words, I am now at step 3. This is the step where you add or subtract equal amounts to each side in order to get what? In order to get the 2 boxes that have the variables in it. You don't have to do the box and circle thing. I'm just making it easier for you to understand what I'm saying here. That's all. You don't have to do the box and circle thing. But I want to get the 2 boxes because they have the 2 variables in it. Okay. I want to get the 2 terms that have the variable in it, in other words, on the same side. And I want to get the 2 terms that don't have the variable in it on the opposite side of where I put the variable terms. So I'm going to just do it a little bit different this time because it really doesn't matter what side you put the things on. I'll move the variable terms to the left this time. In the last problem, I moved them to the right, but it does not matter, okay, what side you do. As long as you put the terms that don't have the variable in it, the constant terms they call it, on the other side of where the variables are. So this is going to be minus z minus 8 when you combine like terms on the left. Here the 3 z's cancel and you get minus 1. Then I need to what? Then I need to move the negative 8 over with the negative 1 because they need to be on the opposite side of where the z terms went. Since that's minus 8, I need to do plus 8, right? Because this was positive 3z, that's why I did minus. You do the opposite. So you get negative z equal to 7. Oh, hey, great. Z's by itself. No, it's not by itself. Okay. Some students make that mistake sometimes. All right. We do have, however, a single variable term and a single constant term. A single term on each side with the variable only on one side. That is when you are allowed to do that division step, the very last step. all right, that's listed right above here where it says divide by the coefficient of the variable term. Oh, but I don't see any coefficient there. Well, we know that when it says negative z, just like if it had said negative x or negative y, doesn't that mean that the coefficient is negative 1? Because remember, negative z means the same thing as negative 1z. All right, it's just that the 1 is invisible. And so we divide by negative 1. Z is not truly by itself until the coefficient of z is positive 1, not negative 1. Now it's positive 1 after you divide by the coefficient there. Okay? And then this would be negative 7, and we did it. We got z by itself. We solved for it because z is not on the other side. All right? We now truly know what z is equal to. This is the solution. This is the thing that if you plugged it into the equation, it would make it true. All right? The two sides of the equal sign would truly be equal to each other when you plugged in negative 7. That's what a solution is. It's what makes the two sides equal when you plug it in. You don't have to do that right now. Okay, not in these problems. Later on, it will be mandatory in some problems, but not these. Okay, so if you're sure that you did all of your work correctly, all right, all of your calculations and everything, this should be the correct answer. There shouldn't be any doubt. Okay. Moving on, you can see once again here we have a polynomial at the beginning of the left-hand side of the equal sign here. There's 3 terms in that polynomial, but there's not a bracket around them. And then the last term, like we saw in the previous 2 problems, the last term is pushed right up next to the bracket so that that means multiplication. There's nothing in between the negative 5 and the bracket. Again, that means what? Because there's no bracket around this, that means you only distribute the closest term there. Okay? Now, when that closest term is negative, you've got to distribute the negative along with the 5, just like I did up here with the negative 1. I don't just distribute the 1, but I do the whole thing negative 1. Okay? So if it's negative, remember that minus when you distribute. So what do we get? Distribute the negative 5, we get negative 10u. Okay, negative 5 times 2u. Negative 5 times negative 3 is positive 15, so don't forget that plus there. You've got to have pluses and minuses in front of each answer when you distribute here. All right. Over here, 1 plus 4, very similar to the 10 plus 2 example. Be careful not to say 1 plus 4 is equal to 5. Okay, you have to distribute the 4 instead. Okay, but again, we have a polynomial. This is 2 terms here with no parenthesis around it, but it is being pushed up next to a bracket. So you have to distribute the closest term 4. Okay, without combining the 2 terms that are outside the parenthesis. All right, bring down the 1. 4 times u is positive 4u, so we say plus 4u. Positive 4 times positive 5 is positive 20, so we say plus 20. And now we are ready to combine like terms because that's the next step here. 3u plus 21 and 4u plus 21. Now we go to that third step where you have to move where you add and subtract equal amounts to each side to make sure that you're moving what? You're moving the terms that have the u in it to one side and the terms that don't have the u in it to the other. Something kind of funny happens here though if I move the 21 first. Okay, I want to talk about it though just in case you ever run into this situation. You'll know how to handle it. Both of these things cancel when you move that over because they're the same number. And so what you end up with is you end up with 3u equal to 4u. Now a lot of students get tricked by this. They say, oh hey, there's a single term on each side, so that's the division step, right? No, Remember I said that not only do you have to have a single term on each side before you divide, but the variable is only allowed to be on one side. Okay? The variable is on both sides here, so we're not allowed to divide yet. See, you still need to do one other thing before you divide. You have to move the 3u and the 4u over to the same side as each other. Remember, we have to move the boxes to one side and the circles to the other side. We haven't moved the 2 boxes to the same side here yet. Now, since there's no terms without the variable in it, there's no circle terms left here. You can essentially move either one of these, okay? Because there's you don't have to worry about having it on the opposite side of where the circle terms were, because the circle terms are completely gone. Okay, so you can go either way on this. I'll go ahead and move the 3u over with the 4u, but you could have done it either way because there's no more of those other terms, the circle terms there. If I do that, I get 0 here because everything canceled. When you combine like terms and everything cancels, that's equal to 0. And then this is 1u, right? Do I need to do the last step now? I do have a single term on each side. I do have the variable on only one side. So I do essentially, theoretically, need to do the last step now. But it's not necessary to do it because of a couple reasons. Number one, the coefficient is 1. So if I divide by the coefficient of the variable term, it's not going to change anything when you divide by 1, right? The second reason why I don't need to do that last step is because the u is already by itself. And the variable's not on the other side either. So, and that's the goal. So that's why the last step is unnecessary. We already have achieved our goal of getting the variable by itself, solving for it. Okay. Okay, you can see that these next 5 problems right here are a lot smaller, okay, and there will be less steps. In fact, they have fractions in it, though, unlike the first 3 problems, but we'll deal with that, don't worry. But what I want you to realize here on the first couple of problems is that they're actually, because of the fact that the fractions in the problem do not have a variable in them, okay, there's a variable behind the fraction, but the variable's not inside of the fraction. That's a big difference, okay? So what I want you to realize is that when you have a fraction that doesn't have a variable in it, it's no different as far as what you do than a problem like this right here. Just like the 3 is a number that doesn't have a variable in it, okay, yes, there's a variable behind it. The 3 is just like the 1/8 then. It's just a constant number. It's not a variable. There's no variable inside of it. And everything else is the same here. You have the times y, and then you have equal to 3. And so my point is that when you have a fraction that doesn't have a variable in it, it behaves in the same way, and you do essentially the same steps as you would if it was just a normal whole number in the place of that fraction. Wouldn't we just divide by 3 right here in order to get the y by itself? So wouldn't it make sense that we would do the same thing here, where you would divide by the 1/8? And then just like the 3's would cancel right there in order to get the variable by itself, in this problem down here, wouldn't it make sense that we would have the 1/8 cancel right here, just like the 3's cancel, thus getting the y by itself here? Okay. And so it works the same way. The problem, though, is that what is 3 divided by 1/8 equal to, though? We got y by itself, but we still got to figure out what this is so that we know what y is we know what y is equal to. Okay, well, and we saw this back in the fraction chapter, chapter 8, we learned that when you are dividing two things, and one of those two things is a fraction, okay, 3 is being divided by this fraction. What you got to do is make the thing that's not a fraction into a fraction, like this. And then remember, when you divide fractions, you're supposed to do the reciprocal thing, right? Where you flip the second fraction. So wouldn't that be like this? And then I can then cross cancel and all that, but there's nothing to cancel here. Okay, you just multiply because there's nothing to cancel. And they're all single terms, so you don't have to do all that factoring stuff either, thankfully. So you end up with 24 over 1, which is, of course, equal to 24, right? Final answer, y equal to 24. Okay, let's do that again. Once again, because of the fact that the fraction here, I know it's negative, but it still doesn't have a variable in it, right? So again, this is no different than if you had like 3z equal to 9. Okay, in other words, if that fraction doesn't have a variable in it and it has z behind it, just like the 3 does, and then you have equal to 9 after that, these two problems essentially are going to have the same steps. So just like I would divide by 3 right there and the 3's cancel, wouldn't I divide by negative 1/3 here? And then the negative 1/3 would cancel over on the left-hand side to get the z by itself? But again, the bigger challenge is to figure out what this is. When we divide a regular whole number like 9 by a fraction, you have to make the 9 into a fraction. And then you do the reciprocal thing. Remember, when you flip a negative fraction, the new fraction is still negative. All right. When you do the flip, it doesn't change the sign. All right. So it's still going to be negative. And then isn't this equal to negative 27? Okay, 9 times negative 3. Okay, we know that that's all that this is. The ones don't change that. It's just 9 times negative 3 is equal to negative 27. There's nothing to cancel here. All right, just multiply the top and the bottom. But remember that because it's positive times negative, we talked about this in a recent section here. Be careful when you're multiplying fractions with single terms everywhere. When you have negative signs involved, make sure you got the correct sign. Positive times negative is negative, and so that's why that's negative 27. All right, but it is when you multiply, it's 27 over 1 normally, but because you got to realize that it's positive times negative, that becomes negative right there, and then that's why the answer is negative. Okay. Now, in these next two problems, you see here that it looks almost the same, but the difference is that the variable, instead of the variable being behind the fraction, the variable is inside of the fraction. But that's okay, because we covered that type of situation and how to deal with it back in section 4.4. Remember, we saw a problem like this. Let me look at this one. This one's easier. See how we had a single term on the top and bottom here, but the variable was on the top? What did I do with that variable? I moved it behind the fraction so that the fraction had no variable in it. And then that told me what the slope was and everything. But I can do that same thing here. Okay, if you've got a single term on the top and bottom and the variable is on the top, you can move the variable out behind the fraction. And that's good news here, because then if I do that here, it will then look like these two problems where you have the variable behind the fraction and the variable is not inside the fraction. Now remember, this is 1w right here. When it just says w, that's the same thing as 1w. And so if I want to, since there's a single term on the top and bottom, I can move the w behind the fraction like that, and now I have 1/5 w equal to 4. Isn't that the same exact thing as these two problems? You got a fraction without a variable in it, 1/5. You got the variable behind it being multiplied by it, and then you got equal to a normal number on the other side. So we do exactly the same thing. You divide by that fraction that's being multiplied by the variable. Okay, you got to pull the variable out behind it though first, and that's why we did that. But then the 1/5 cancel and you get w by itself. But then you do that thing where you make the 4 into a fraction, because we're dividing it by another fraction. And then you do the reciprocal thing. What do we get? 4 over 1 times 5 over 1, which is going to be 20 over 1, right? And as you guys know, 20 over 1 is the same thing as 20. Okay. Problem G. Same thing, okay? You've got a single term on the top and the bottom. The negative is not going to affect that. In fact, the negative just makes it similar to this one right here, where you got the negative in front, but you still got the single term in both the top and bottom. You still are allowed to move the x behind it. Again, this is from 4.4. You can move the x behind it. Same thing here. We know that there's an invisible 1 right here, because when it says n, that means 1n. And so if you move the x behind it, you guys, we then get this right here. Okay, you have to write the 1 if the 1 is all that's there. after you move the n out of there. We know the 1 was invisible, but now it has to be visible. You can't just leave the top of the fraction blank. Now we divide out. It's very similar to problem E, where you had to divide by negative fractions, so just be careful with the negative there, but otherwise it's very similar to this one. Okay, the negative 1/11 cancels here so that the n is by itself. Okay, and so we get what? We get 7/1 being divided by negative 1/11. Since you're dividing fractions, you multiply by the reciprocal of the second fraction there. Isn't that going to be equal to negative 77? Negative 77/1, which is the same thing as negative 77. Okay. This last one here is a little bit different because this time the fraction is not on the same side as the variable. In the previous 4 problems it was. Okay. What I want you to realize though is, again, the fraction doesn't have a variable in it, right? So as I mentioned previously, because it doesn't have a variable in it, it behaves in the same way as just a normal number that doesn't have a variable in it. Like, for example, I'll just say 5 is equal to negative t right here. So if I pretend like the 4/9 is a 5, my point is that you do the same steps in the real problem that you do in this practice problem down here. Wouldn't I divide by negative 1 to get the t by itself? So wouldn't it make sense to divide this by negative 1 as well? Okay, and it's very similar to what we've been doing, where if you're dividing 2 things, the t is now by itself. But if you're dividing 2 things and one of them's a fraction, this time it's the top one that's a fraction as opposed to the bottom one in the last 4 problems. The top one is a fraction, and you're dividing by a regular number, negative 1. Okay, either way though, if you're dividing 2 things, you guys, and one of them's a fraction, doesn't matter if it's the top one or the bottom one, okay, you make the other one into a fraction. So you make the negative 1 into a fraction. And then and I apologize, I haven't flipped it yet. Okay, but you make it into negative 1/1. Okay. I got a little bit ahead of myself there. I need to be more careful. All right, so I'm dividing by negative 1/1. I'm just taking this and I'm transferring that over here, making the negative 1 into a fraction. But then I have to multiply by the reciprocal. That would make this 1/-1 now. Nothing cancels, so I can multiply, and I get 4/-9. And there you go. That's already in lowest terms, so you can leave it like that. You can also put the negative in front of that fraction because it means the same thing. Okay, it means the same thing there as we've talked about before. If you have a negative just on the bottom, it's the same thing as having the negative on the outside. All right, as long as both of these are single term. All right, simple little single term on the top and bottom, that type of fraction, you can do that. All right, so you can also say this is what I'm saying. You can say it either way, though. You don't have to say it both ways. Either way is fine. Okay, so that is these fraction problems here. What I'd like you to do right now is on the second page here, please do 1 through 5. 1 through 5 right here. Hit the play button. We'll look at those answers. And then at the very bottom here, there's a very rare situation that occurs with linear equations sometimes. We'll look at that at the very end. Don't look at these yet, though. We'll do these together. Just do these 5 first, okay? And then we'll talk about those at the end. Okay, so hit the play button and we'll see what the answers look like. Okay, let's take a look at number 1 here. Again, there's no parentheses on this one. When that happens, you just skip the parentheses step, okay? Just kind of similar to when we had the fraction problems here, where we skipped the first 3 steps on those problems, didn't we? Okay, there was no parentheses, there's no like terms to combine. We already had the variable term on one side and the term without the variable on the other side. So that's why we went all the way to the 4th and final step of dividing out. Okay, sometimes you don't have to do all the steps. Okay, this is another example of that here. But we do need to do the other steps here because we do need to combine like terms. There are like terms to combine. We get 5x minus 6 and 4x. We then need to what? We then need to realize that the 5x, let me get rid of that canceling here because we're not ready to do that yet. The 5x and the 4x need to be on the same side, but they need to be on the opposite side of where the 6 goes, right? Okay, so we want the two boxes here, the ones that have the variables in it, to be on the opposite side of where the one without the variable in it goes. Okay, so let's move the 5x over with the 4x, because since there's only one of the terms without the variable, might as well just keep that where it's at, right? So I'm going to subtract the 5x over, and I get negative x equal to just 6. 6 is all that's left on the left-hand side. Remember, x is not by itself, you guys. You got to divide out by negative 1 when it's negative x. And we are on the division step because you got the single term on each side, right? With the variable only on one side. And so we divide out on that step and we're done. Number 2. Got to distribute first. Remember, when you have just a minus in front of the bracket, but nothing in between the minus and the bracket itself, all right, that means that you distribute negative 1, right? Just like we did on the very first problem on the first page when we had the minus 6 minus bracket thing, okay, and we distributed the negative 1 right there, all right? Same thing here. There's an invisible 1 right there. You distribute that, and we get this right here. Okay, and so the negative x, you see there I distributed, or I didn't distribute, I already did that. But I need to what? I need to move because there are no like terms to combine, so we skip the second step on this problem. There's no like terms to combine. So on the third step, we need to move the terms with the variable in it to one side and the terms without the variable in it to the other. It doesn't matter which one you move first, as long as you repeatedly add or subtract equal amounts to each side until you get that thing where you got a variable term on one side and then a term without the variable on the other. So I went ahead and I moved the x. If you move the 4x, that's okay. I'll show you that in a minute if you did that. I'll show you how it should have come out. And so I end up with 5x plus 6 equal to 2 because these cancel right here. Okay? And now I'm supposed to move over the 6 with the 2, right? Because they need to be on the opposite side of where the 5x is located. And that gives me 5x equal to negative 4. Now, if you had decided when you did the problems yourself, if you had decided to move the x terms, the boxes, over to the right instead of to the left like I did, then on this particular step, your problem should look like this right here. 4 equal to negative 5x. That's correct. I know it looks different than mine, but it's supposed to because you moved it to a different side. Yes, the signs are different. That's not a surprise. Don't be alarmed by that. The answer will still come out the same because you're doing it right. You are. Okay? I'm supposed to divide by 5, right, because I have 5x. And therefore, I get negative 4/5. You, on the other hand, if you did it this way, you're supposed to divide by negative 5 because that's the coefficient of x if you do it this way. Either way, you're going to end up with positive divided by negative, and so you're still going to end up with negative 4/5 either way. And so, even though it looks a little different there, in the very end of the problem, it ends up as the same correct answer. Okay? So don't worry about that. In the next one here, we have, again, two terms on that side of the equal sign outside of a parenthesis, but the two terms are pushed up next to this bracket here where the negative 8 has got nothing in between the negative 8 and the bracket. And so that means you distribute the negative 8, don't you? Go ahead and distribute the 4 as well. There's nothing in front of the 4 there. It's just a single term, so that you just distribute that. And we get this right here. Okay. We then combine like terms. Okay. And that means that we now have what? We now have a couple of terms without the variable in it and a couple of terms that do have the variable in it. So I need to move the negative 12t and the negative 8t to the same side, and I need to move the 32 and the 16 to the other side. I went ahead and moved the t terms first, but you could have moved the 32 and the 16 together first. That's fine. I moved the 12t over with the 8t, and I got 4t. Okay, so 32, 4t plus 16. So now I'm forced to move the 36 over with the 16 over with the 32, so that I'll have a single variable term, and then on the opposite side a single constant term, meaning a single term without the variable. That's called a constant term. If you did it the other way, where you put the t's on the left, it should look like this, but again, you're going to get the same answer I do. If you did it my way, you divide by 4. If you did it this way, you divide by -4 because that's the coefficient here. Either way, you're going to get +4 as your answer. Number 4. Distribute out the 10, distribute out the 8. Remember, the 14 is separate because when the bracket ends and you have a plus or minus outside of the bracket behind it, that does not get included in the distribution here, okay? So it comes out like that when you distribute the 10 and the 8. Then we combine like terms. Then we need to move what? Then we need to move the 20y and the 16y to one side. And I need to move the -10 and the +22 to another side, the other side. I went ahead and moved the y terms. It's not an easier or harder way to do this normally, okay? So if you're wondering why did I move it over to the right here, the y terms, there is really no reason. I just had to pick something, okay? So I move that over. Now I get this right here. These cancel out right here. The 20y's cancel. Now I have to move over the 22 with the -10 because those terms need to be on the opposite side of where the y terms went. And you get this right here. If you had moved the y terms over to the left, it should look like this. You would divide by 4 there. But if you did it my way here, you would divide by -4. And either way, you're going to end up with +8. Negative divided by negative is +8. Positive divided by positive is still +8. It comes out the same in the end. Number 5. Again, you have a constant fraction, no variable in it, being multiplied by a variable behind it. And then you have a normal constant number, no variable over here on the other side. When that happens, you divide by that fraction, and it gets the x by itself. The -2/5 fractions cancel. But you have to do that thing where you make the 20 into a fraction like we did on the first page, and then you flip the second fraction. Since we're now multiplying, you could cross cancel. Okay, and something does cancel here this time. The 20 and the 2 become 10 and 1. And so we're left with what? We're left with 10 over 1 times -5 over 1. Right? And that would be -50, wouldn't it? Let me move that up here. -50. Final answer, x now by itself is equal to -50. Okay? So that concludes those 5 problems right there. We have 2 more problems I want to look at. They have this is a very rare instance, okay? Usually when you solve a one-variable linear equation, over 90% of the time, you are going to just get the x by itself like you normally would. You're going to get your answer. Everything's going to be normal, all right? But there are some rare cases where the variables actually disappear completely from the problem while you're going through the normal process of solving it. I know that seems kind of strange, but it does happen, and I want to make sure you understand how to respond to that with an answer. It's not one of those things where it's, oh, I don't say anything, I just skip the next problem. No, you give an answer, but there's a certain way you have to word that. Okay, so let's take a look at that. In both of these problems, the variables are going to disappear here, and but in a different kind of way, and I'll explain that. So I'm just going to go ahead. I've already done these problems here. I'm just going to go ahead and show them to you here. I'll go through it slowly here so that you have time to write it down. But what we're going to do here is the normal process. And then, because you're not supposed to know which problems the variables disappear on. So we're just going to go through the problem just like we normally would, all right? And then when it happens, when the variables disappear, then we'll talk about it. So we're going to distribute the 3 first here, aren't we? Not to the 10 though, right? Because it's behind the bracket there. And we get this right here. Okay? So then what do you do after you distribute? Combine like terms, right? Okay? And so if I combine like terms, I get this right here. And let me get rid of those slash marks there because we haven't actually canceled yet. It's going to cancel here in a minute. So it's negative 21n plus 22 is equal to negative 21n plus 22 again. They're actually both exactly the same. That's interesting. Okay. So what I do now is I want to move the variable terms to one side. Okay. If I do that, don't they both cancel? Because they're the same term. And so they both cancel, and we just end up with 22 equal to 22, but the variables are completely gone. Okay, here's the thing, you guys. If you're in the process of solving the equation, and the variables completely disappear, but you get a true statement, and what I mean by that is 22 and 22 truly are equal to each other. If you said 22 equal to 22, if you said that to somebody, you would be saying something that was true, right? 22 is equal to 22. Okay? Since this is true, and that's not your answer, I'm just saying that it's true. But that's gonna matter here as far as determining the answer. Okay? Since it's true, then here's how it works. When the variable disappears completely and the resulting statement is true, on the next problem it'll be false. That'll be a different answer. But when it's true, then the answer is all real numbers, meaning every number in the world, okay, at least every number that we're looking at here in Math 51. Okay, you'll see different, you'll see what we call imaginary numbers in Math 71, but in Math 51, if I say all real numbers, that's every number in the world as far as what we know about numbers at this point. So every number in the world, you guys, is a solution to this. That's what happens when the variable disappears and you get something that's true after that. Okay? So that's what you circle there. Every single number in the world is true. Okay? So usually we just get the one answer, like x equal to negative 50 that we got on the last problem, or x equal to 3, or x equal to 5. Okay? But there is this rare case where the variable disappears. What happens if the variables disappear, as we move on to the last problem here? What happens if the variables disappear, but you get a false statement? We'll talk about that. So, distribute out the negative 6, not the 16, right? All right, because the 16 minus 6 doesn't have a bracket around it, so you just distribute the negative 6 only. We get this right here. All right, and then we combine like terms after that, correct? So if you combine like terms, you're going to get this right here. Again, let me get rid of those slash marks because we're not ready to cancel that yet. I've done this problem before, and so that's why those slash marks appear there. But let me get rid of them so you can see this better. So we got 13z plus 2 is equal to 13z minus 2. And so if I now move the, because this is the part of the problem, right, where you have to move the, since we already combined like terms, we're supposed to move the z terms to one side and the other terms to the other side, right? But if I do that, and I move over the 13z, again, what happens? The variable terms, or in the variables as a result of that, the variable terms cancel, and therefore the variables do too. And you're just left with these two numbers, no variables left, 2 equal to negative 2. So same thing as over here, the variables disappeared. But the difference is what? The difference is 2 and negative 2 are not equal. If I said, hey, 2 is equal to negative 2, I would be saying something that's false, right? This is false. When the variables disappear and the resulting statement after that is false, then it's going to be no solution. In other words, when the instead of rewriting this whole paragraph, I just said what I'm trying to point out here is that this problem is the same, where when the variable disappears completely, But the difference is that instead of it being a resulting statement being false or being true, this time in this problem, it's false instead of true. So that's why I'm saying if it's false instead, then instead of it being all real numbers, it's going to be no solution. So let's review here. Usually over 90% of the time, whenever you do solve one variable linear equations, you're going to get an answer. Okay, you're going to get x equal to negative 50 or x equal to 5 or x equal to 3, whatever. Okay, but there are these rare cases where you're going to get the variable disappearing. If it does, your answer is either going to be all real numbers or it's going to be no solution. So there's 3 different possible things that could happen when you solve a one variable equation. But almost always, you're just going to get x by itself, and it's going to be equal to some number. Okay? And so wanted to make that clear. So we'll see you back next time for section 7.5. That'll be another one variable equation type of thing, but it'll be a different type of equation. It won't be a linear equation, so the steps will be completely different. Okay? In the meantime, though, let me know if you have any questions about this, and have a great day. We'll see you for section 7.5.